So how do we build this, right? It can get quite advanced if I don't know what the skill levels are and the experience of everybody on the call is from a data center and a routing and a BGP or VXLAN perspective, but we basically have two different components. And before I explain that, what I'm going to do is click on the Cisco design guide, which hopefully this link works. So this is the ACI multi-site white paper, right? And there's a couple of key things that I want to, or a few key things that I want to highlight in Cisco terminology, right? So you've got the multi-site orchestrator. So this component is an inter-site policy manager. So I think I've kind of covered that. But the multi-site is all about two sites actually, or more. Two sites or more looking like one site. So that's where when you have other design scenarios like multi-pod, for example. Multi-pod would be, you know, separate. I can't remember off the top of my head, but it'd be like separate policies. So you need to configure the APIC for site 1 and then configure, or pod 1 and then configure the APIC for pod 2. Whereas like if you with multi-site, you can push the policies out to both pods at the same time from multi-site orchestrator, and then on the back of that's how the network behavior comes into play. So for example, well, we'll talk about it in a second. So the inter-site control plane. What is a control plane? The control plane, if you don't know, is basically the routing and the network state. So if you remember, like when I said that there was one, you can probably look at it here. If you look at this diagram here, we have like a VM here. The control plane identifies that, say this is VM2 and this is VM1. The control plane understands that VM2 is in this data center on the right, and the control plane understands that VM1 is on this data center on the left. And then the data plane is, and that's achieved by BGP EVPN host routes being propagated between the site. So I've got an example of this. Let's say this VM is vMotioned across to this site. What actually happens there is like the ACI fabric understands that server has moved to this site, but then it lets this data center know that server is now over here. So if a server over here needs to talk layer 2, it understands that it's moved and it builds a VXLAN tunnel from the switch that it's connected to over the IP network into the switch that the moved server is on. So that's like a layer 2 tunnel that goes over the IP network and then just sends the frame across there. So it's an inter-site control plane, which is the BGP EVPN side of things, and an inter-site data plane, which is the VXLAN. And that is basically summarized as host routes are advertised across sites via EVPN, and VXLAN is capable from a leaf node switch on one data center and building a tunnel from that switch, which is layer 2, and then hands off to a VLAN effectively at the other data center. So that's I'll put the links to this document because it's really good in the notes of the YouTube video. So in order to propagate that BGP EVPN, what do we have here? It's a simplified version, or it would seem simplified, but it is a simplified version of what you had seen before. There's a couple extra switches on this right-hand data center which are just Visio typos, so ignore those. But what do we have here? So we basically have an OSPF network. So OSPF process 1. The green circle in here is the backbone, and that's basically run between the two data centers. The blue OSPF1, area 122 and 222, you can kind of like just put them to the side for a minute, because they're not really that involved in the fabric. That's more like outside the fabric. And then we have OSPF 1 area 112 and 212, which are down the bottom here. And that's basically, so how does this work? Effectively, this is the underlay network that allows for the BGP, EVPN and the VXLAN to happen, right? And how that happens is that, first of all, what we do is we build, like, we have to build a BGP session, first of all, from that data center to that data center. So that's an EVP, well, that's a BGP session, right, that we can then use the EVPN address family between the data centers. And we advertise the host routes of the, the various spine switches and the leaf switches across between the data centers, across BGP, and then from an EVPN perspective, we can then inject host routes, and that's where I'll show you in a minute what happens when you move a VM or whatever, or if you move a service across. So the other thing to call out here is, within the fabric we have two separate BGP ASs, so it's an eBGP peering, and then EVPN running over that. And OSPF is being used to advertise the effectively the IP addresses that are being used as the BGP endpoint address or BGP neighborship address. Okay, so this really just reiterates what I was actually talking about. On this diagram, we actually have 4 segments of the network, or that's what it appears like now, right? So we have the data center 1 and the data center 2, which is like off fabric, and then we have the data center 1 and the data center 2, which is the fabric or ACI fabric, and that's where all our servers are connected to. In this particular scenario, I mentioned that we were using GOLF EVPN. Oops. Erase all that and then stop the pen. So this is relevant to highlight. So what we have here is, if you look at this red line in particular where it says GOLF Layer 3 out, eBGP, EVPN, OpFlex, host routes and prefixes. What that basically means in English or non-techie jargon is that we've got a layer 3 link from the spine switch in the ACI fabric, and we have an eBGP session, or a routed, a layer 3 session, I should say, because I don't want to complicate it, but we have a layer 3 routed link from the spine switch, where that green line and red line are going into, up to the DCI GOLF VDC. And that's basically coming out of the fabric, right? So this is something that never used to be available in ACI. So you used to have to do what I'm about to draw. If you have that red line, and it used to actually come down, used to be, and layer 3 out is just basically how you get out of the fabric. It used to have to be on Nexus 9K leaf switches, and they were normally like dedicated for ingress, egress, in and out of the fabric. But that's moved on, and then it's now possible to do it using GOLF. How commonly it's used, I don't really know in the wider scale of things. I think it should, in my head, it makes sense for it to be the preferred option, but there might be some bugs and things like that, I don't know, that I'm unaware of. But this is certainly how worked on ACI designs in the last sort of year to 18 months. This is the approach that we've taken. And going back here, you see that, you know, the connectivity from the spine switches goes out via the spine switches rather than the layer 3 out. But if you look at some of the older design guides, or if you just search for layer 3 out on a layer, kicking about that. So, what else do I want to talk about here? So, if you see in the diagram, so the red lines going from the BGP fabrics to the DCI Golf VDC, those are physical / just IP transit routed links, layer 3 outs. The green line, the green dashed line, is the ACI control plane. So that's the EVPN, which basically communicates that which servers reside in which data center. Let me see. And then what's probably missing from this diagram actually is like if I then say, right, this has a node that needs to speak to this node, then in red is a VXLAN tunnel, then that's built as required. Oops. Bit of lag on the screen, but yeah, so that's the VXLAN layer 2 tunnel. So that this one here, if it has a host or a server connected to it, needs to speak to a server on this switch, and it knows its IP address. It learns via the spine switches, which have learned via EVPN that host resides on this side of the network, and it builds a VXLAN tunnel between the leaf nodes on either side of the network across the IP network link or data center interconnect, and that's how they communicate. One more slide after this. So this diagram shows a scenario where a server moves. So let's say we have a server which moves to another data center, and there's stateful devices in place. Now, if this moves into this data center, and then let's say I'm a user here, and I now start communicating with that device, then that's fine. What will happen here, because we're using EVPN, and it depends how, this is what I mean, it depends how you configure your network and how you configure your devices north or upstream from the ACI fabric. So what we have here is we have the server moves across, and then the spine then advertises the host EVPN route into the core switch, and then you see this green line, it advertises that the fact that host route is now present in data center 2. And what that means is, because a host route has now been propagated into the wide area network, saying that you have to come via data center 2, or there's a host route in for the example subnet here, or server is 10.10.10/32. So 10.10.10.10. So in order to get to 10.10.10.10, you follow this purple dashed line, which is on the screen. So you see up the top here, we've got received a host route for 10.10.10.32. But let's say this went down. Well, that's a terrible colour. Let's say that this circuit went down. How would we get to 10.10.10.32? Well, we would still receive you know, the prefix 10.10.10.0/24 being advertised out of this data center. So we would come in here, down into the core, and then route across, because this is aware that, or maybe it would be here, I don't know. It's been a long session, but anyway, in this rooted environment, it would know that the host route for 10.10.10.10 was located down at the bottom. And this is where, you know, why the data center is so complicated. Why is it important to propagate the host routes when they move? Basically, we don't have a firewall pictured in this diagram at the moment. But if we did, and I drew one in, and let's say there was a firewall here and a firewall here, right before you got to, and there typically is. I never really covered it in that much detail in the slides, but there normally is within the ACI fabric. But if let's say that you started coming along this path in order to actually let me clear that. Let's say, imagine the firewalls are still there, and let's say you actually switch the pen off. That didn't help. Oops. Let's say we started coming this way to get to this server, and then it moved, and then the firewall here has all the state for that session, and then the server moves across here, and a host route is advertised out, and it says, all right, okay, now I'm going to follow that purple line, and there's a firewall here. This firewall has no knowledge of the state that's already been coming in via the red route. So that can break the session and then black hole traffic. So that's why we need to know, you know, where and that's where EVPN comes into play. Okay, so let's just move to the last one. So this is just another. Again, we could talk about this for ages, and this actually touches on the firewall stuff that I was just talking about. But I'm just going to talk about the different considerations that you need to think about when you're integrating, like a legacy data center, for example. So if you imagine that this is your legacy data center. So if you remember back to the architectural overview, right, and that's just a plain chassis-based data center, for example. If that was a plain chassis-based data center, and let's say, to keep it very simple, it was a Cisco 6500, all it had was line cards on it for port connectivity, no firewalls, nothing, and it had 10 server subnets and VLANs on it. But, and let's say out of those 10 server subnets and VLANs, 8 of them were going to be completely re-IP'd, and in this fabric, they were going to be either replaced or completely like the services were going to be replaced completely with a new application, or the servers weren't affected or whatever. But then we had 2 subnets which actually needed to retain their IP addresses for whatever reason, and this argument comes up all the time, right? And then off here you've got all your legacy sites. You get the picture. That's your legacy site, so that's your legacy routers there. And let's say the legacy routers have to go via the legacy data center, or there's a WAN migration going on at the same time, but for the purposes of this discussion, you have to go through the legacy data center in order to get to the new data centers, which are Colo 1 and Colo 2. So you can see, even just explaining that in a couple of minutes, how complex that is. What you then need to think about is like, right, okay, 8 of those subnets we're golden, easy, no issues. All we'll do is we'll route in from the site, we'll go over the WAN or whatever into the data center, and then route down into the ACI fabric. And as we say, Bob's your uncle, job done. And that goes for going to data center 1 or data center 2, whatever you need to do. Now, the two subnets that are problematic, what we need to do is think about how we're going to integrate those into the legacy environment. The legacy environment into the new environment. And that's where you might actually need to get, for example, a layer 2 point-to-point link from your old data center to your new data center. And I've highlighted that here. I don't think I even need to draw. I just need to zoom in. But if you look here, we have the legacy data center, existing subnets and apps. And we've got one in solid green and one in dashed red. And this is actually based on a migration that I have done before on an ACI migration. So what we've done is we had a layer 2 out onto somewhere within the ACI environment. I can't remember exactly where. I think it was on the leaf node. So we had a layer 2 out and mapped the endpoint groups to the VLAN, which was in the legacy data center. And we had two links. So we had one from the legacy data center. So let's say it was a 1 gig link. One from the legacy data center to Fabric 1 in colocation data center 1, and another separate physical link to data center 2 in colocation 2. But we kept that one shut down, because the reason that we've done that is because if you look at this, we've got potentially two layer 2 links, plus we've got all the VXLAN layer 2 stretching between sites, plus we've got layer 3 interconnects, and then we've also got traffic coming in from the internet via VPN or whatever. So the point here is, when you're looking at a migration like this, you've got the key point, and I cannot emphasize this enough: know your traffic flows. It's not always possible, but to be honest, I cover this in my training courses that I've got coming up, where there's ways and measures that you can capture this type of information, like with request for information. You can press customers to speak to the application teams, but simply by getting them to fill out things like known applications in the business critical applications. Where is it located? Does it traverse the WAN? Does it traverse the internet? Where is it hosted? How many users are dependent on it? This is imperative, and I cannot say this enough, absolutely imperative to any data center migration. And you will come up against barriers. You will come up against people saying, I don't know, someone else looks after that, or you tell us. That is firmly whoever the organization that's carrying out the data center, it is their responsibility to ensure that there's an understanding of the traffic flows. And it doesn't have to be every server to every server. It's things like, we've got these many applications in the cloud, we've got these many applications in colocation 1, and there's a couple of applications down at site 1, 2, 3, because that's the legacy accounting or ERP system that's been there since 1994, and we're migrating that next year. So I'm sure you've heard all these types of things before, but that's the key takeaway here. It isn't really to say this is how you migrate your data center to an ACI. It's like getting you to think, right, if I put a layer 2 or a layer 3 interconnect and a route, what's the possibility for a loop? What's the possibility for an application to break because the stateful firewall is coming one data center and out the other? Because at the end of the day, if something does break as a result of it, it doesn't matter which team it is, it's probably the networking team that's going to have to resolve or identify what the problem is, in my experience anyway, or help. So, on that note, that concludes the presentation. I did think it was going to go a bit longer, and it's went for about an hour and a half rather than an hour, but I probably should have budgeted that anyway. We covered quite a lot. Only one question amazingly came in, so you either all understood what I was saying or you're shy. But we've kept everybody who joined pretty much. We had 19 people join, and we've got 17 on now. So I'd just like to thank you for your attention and patience, and I hope the session was helpful to you. And as I mentioned, I will break it up into probably 3 or maybe 4, because it's quite a big one, 3 or 4 different YouTube videos and put it on the M&B Networks YouTube channel. The stuff's on the screen if you want yeah, I've got like this as standard. I normally put a Google form together just to get feedback if there's any improvements or whatever I can make. It'll be going on the YouTube channel. Website is there. Consultancy training, moving into some training services and things like that as well. And if you have any general queries or want to reach out and contact us, the email address is there, designteam@mnbnetworks.tech. So I'll send out the feedback form. If you've got a couple of minutes spare, that would be fantastic. And other than that, I wish you a pleasant evening, morning, afternoon, whatever it is, wherever you are.